So how can we create multiple containers? As is the only solution for this. This is even more efficient if you work in a studio, which is the idea. The way I do this is I create a grid. Everybody might have his own technique, but this is mine. So I go to frame. Maybe it could be the first one. We can create a time shift and keep it there just for the purpose of creating the multiple containers. You can use this expression. Now we're going to append maybe a null here. This is going to be centroid. In the grid, we're going to look for this centroid using the centroid function. Centroid. And you look for that null. It's going to be dx. Copy, paste. You need that to be only on X and Z. So this is now using the center of this object. You can also use this add spare input. We will try this later. Just to give you the choice of using a spare input, let's create the bounding box that goes here. Let's use that, add spare input, and connect the centroid there. Now you can use the bounding box expression, but instead of looking for the navigate to this node here, the null, you can just use -1 and use dx size, and you're going to do the same but on Z. Okay, everything seems to work. Now what we're trying to do is keep exactly this the size of the element that we have for the grains. We can also move this up. And we're going to get our containers for the simulation. We're going to grab it from the rows and columns here. So we can do something like 4, maybe the opposite, like 8 and 4, more square. This might be a lot because now we have 16, let me see, we actually have 21 primitives that will be the equivalent to 21 containers. It's the equivalent to 21 containers. That might be maybe too much. Let's see, 3 here. Maybe we can do this. This is better. This will be 14, I believe. Okay, this might work. Now we're going to use the facet to get unique points. That means that if you go here and check how many points you have, it's 24. But here it should be 56. It's because now every primitive here has its own number of points. They are not joined or merged. They are independent points. And now we can use the primitive properties and check they are all separate. You can see they're all separate. Now we're going to extrude this to cover the area for the simulation. And since the setup is going to use independent containers, we might need to use a for each. Let me see if it's better to extrude first. I think so. Double check that you have the output back and then just extrude this. Okay, now if we use a connectivity, we can double check that every cube is a class. Go use primitive for that, and you can test it using a BLAST. So class equals 0, for example. That would keep only one. This is what we want. This is perfect. But we're going to use a for each now. For each primitive. And that way we can simply go here, single pass, and this should be a class here. Let me just use the setup that by default Houdini has for each connected piece. This will work perfectly. And then we can see that every container is now one pass. Okay, now we need to delete points based on the container. That way we're going to simulate just that portion inside the container. For every container we're gonna simulate, run the simulation for the grains that are inside. In order to do that, we use a group. We of course are gonna take the points from here, but just to check, let's start it from here because this has already all the points. And that will help us to visualize this better. And on the second input, you connect the connectivity, the grid extruded that we just did. And we're going to change this from primitive to points. And we're going to enable the bounding object here. Now we can see every container is going to select that group of points, of particles or grains. Just I'm going here. We're gonna blast this. It's a little bit slow. Sorry about that. Let's put a blast here. Append a blast right after, and select group 4. This is what we want. So now if we go here, we can see every container has a group of points. And now we can start using this to simulate. Let's check one that is yeah, one of these on the front, or maybe on the second row. That one, that would be a good choice to start. And remember to disconnect this from where it is right now and connect it on the blast. I'm going to organize this a little bit better. Actually, I'm going to try first connecting this after the cleaning. This attribute wrangle is for cleaning. And then the rest, actually we can connect this here too. This will go after. Call this mold V and P scale. So now that we have this, it's better even to visualize our densities and velocities. All the volumes we have here, we have created. I'm going to get rid of that blast because I need to keep the density and the velocity. Density and velocity, as you can see here. Okay, again, let's go back to our basic setup and grab the rest. Copy paste that, see what happened. This should start on 980, that's correct. Let's just check if there is something happening here. I'm gonna pause my video and create a play blast and see what's going on here. Okay. This is definitely nothing yet. I mean, it's working. Everything is connected. Everything is working properly, except that we need to tweak values and start playing with, resolution, all that. First thing I'm going to do is remove wind force that I might have somewhere there. Then start tweaking and looking for the resolution and the values of the vorticities and all that. Let's go ahead and do that. Okay, go into shape. The first thing, I don't want this wing here. And I decrease the voxel size. This is still on the Pyro solver. It's still referencing the voxel size from here because we did that in the simple setup that we created in the beginning. So that's good. So changing that here will automatically update this value here too. Let's go to something like, for now, just 0.02 because I need to tweak values and do some tests to get the right behavior. Okay, let's continue on the next chapter because this chapter might be too long already. So let's start tweaking values for our Pyro sim and get the thing DOS behaving the way we want.